pendulum clock loses 12 seconds a day if the temperature is 40 degrees Celsius and gains 4 seconds a day if the temperature is 20 degrees Celsius. Temperature at which the clock will show correct time and the coefficient of the linear expansion of the metal of the pendulum shaft are respectively. 4 options are given to us for satisfying the need. Now, the thing of understanding is pendulum clock loses 12 seconds a day, pendulum clock gains 4 seconds a day. Why this happens? It happens because of variation in temperature. We know that periodic time of oscillation of pendulum is given by formula 2 pi under root of L by G, where L indicates the length, and with increase in temperature, length increases. If length increases, periodic time will increase. That means it is going to take larger time for the pendulum to complete one oscillation. So, it will not be able to perform the sufficient number of oscillation at the end of day, and that is why the clock will not show the actual time, but it will show the time lesser than the actual time, and that is why it is written that the clock loses 12 seconds a day if temperature is 40 degrees Celsius. At the same time, the same reason can be given for gain of time, that is 4 seconds a day when temperature is 20 degrees Celsius. It simply means that the temperature should be somewhere between 20 degrees Celsius and 40 degrees Celsius. That is, we are talking about the correct temperature. So, automatically we can say that option B and option D will be ruled out because they are showing temperature 60 degrees Celsius and 55 degrees Celsius. Now, on that basis, first of all, we will try to frame the problem like this. The total time which is shown by a pendulum clock is dependent on oscillation number. So, if n is the number of oscillation performed by the pendulum clock and every oscillation corresponds to periodic time t, then small t indicates the total time which is equal to n times the periodic time. If there is any error in the periodic time, and that will arise because of the length error, or there is change in length because of temperature. So, because of that, since the periodic time is going to change, then that is going to affect the total time. So, fractional change in total time, we can write delta t by t is equal to n is the number of oscillation. So, there is an errorless quantity basically. So, that is equal to the fractional change in periodic time delta capital T by capital T. Now, for pendulum we know that periodic time is T is equal to 2 pi root of L by G, and fractional change in periodic time is dependent on length. G is going to remain constant at a given place. So, delta T by T is equal to half delta L by L from our knowledge of the fractional changes. And we also know that the linear expansion of the rod in pendulum or the shaft of pendulum, delta L is equal to alpha L delta theta, where we know that alpha is coefficient of linear expansion of the metal of which the shaft is made, L is original length, and delta theta is temperature. So, that also gives us delta T by T, that is fractional change in periodic time, is half alpha delta theta. By placing delta L by L, if you see delta L by L, it is alpha delta theta. We have already seen that fractional change in periodic time is also equal to the fractional change in total time. So, we can say that delta small t by small t is half alpha delta theta, where delta theta is change in temperature. So, we can write this as theta minus theta 0. So, now finally the equation that is available with us is the change in time measured by the pendulum is equal to half into alpha into total time into difference of temperature, where theta 0 is the original temperature and theta is the temperature of consideration at which the time is having some error. Making use of the first condition, that is when clock loses the time. So, when clock loses the time, it is not going to show the actual time but lesser than what is actual time. So delta t is 12-second, negative sign indicates it is losing time. At that time temperature was 40 degrees Celsius. So that gives us framing of first equation. And when clock gains time, that is in winter season, so it is given to us as 4 seconds, and that time temperature is 20 degrees Celsius. So that gives us framing of second equation. So if we divide these two equations, that is minus 12 by 4, that is minus 3, half alpha t will be cancelled, 40 minus theta 0 upon 20 minus theta 0. So that on solving gives us theta 0 is 25 degrees Celsius. Putting a value of theta 0 in any of the expression, that is in this expression or in this expression, we get alpha as 1.85 into 10 raised to minus 5 per degree Celsius. So the correct option in this case is option A.